easier nanoscale manufacturing technique. While there is much excitement reported around developments in new manufacturing technologies in the areas of robotics and 3D printing, there is much more research being done in the development of nanoscale manufacturing procedures. Nanoscale manufacturing involves scaled-up, reliable, and cost-effective manufacturing of nanoscale materials, structures, devices, and systems. It also includes research, development, and integration of top-down processes and increasingly complex bottom-up or self-assembly processes. Scientists at the University of Chicago and Argonne National Laboratory have just reported a newly developed method for precisely patterning nanomaterials. This breakthrough could open a new path to the next generation of everyday electronic devices. The paper published Direct Optical Lithography of Functionally Inorganic Nanomaterials on 28th of July reported that this method can be used in everything from LED displays to cellular phones and solar cells. Their breakthrough involves new photolithography procedure. Normal photolithography is carving a stencil out of a layer of an organic polymer by laying down a patterned mask and illuminating it with ultraviolet light. After the new material is deposited on top, the polymer stencil is lifted off to reveal the pattern. The fabrication of any nano device involves several cycles similar to that mentioned even for a single transistor. The main limitation of this method is that it can pattern only certain materials. The new technique, called Dolphin, makes different nanomaterials directly into ink in a process that bypasses the need to lay down a polymer stencil. The research group carefully designed chemical coatings for individual particles. These coatings react with light, so if you shine light through a patterned mask, the light will transfer the pattern directly into the layer of nanoparticles before wiring them into useful devices. The publication reported that the new method results in comparable quality patterns to that produced by normal photolithography. Thus, it can be used for all other applications and manufacturing of nano devices. The development of these nano-manufacturing procedures is essential for supporting the new devices revolution.